Ahora sí. Pero ¿qué tal, gente? ¿Cómo están? Aquí estamos un día más en directo. Hoy estamos con un directo del lanzamiento del cohete Electron de Rocket Lab.
My name's Muriel Baker, and it's great to be with you for our live coverage of the dedicated launch of the Monolith small-sat mission for the United States Space Force. Today's launch window is approximately 2 hours. The weather is looking good, and our operations team are not working any issues with the launch vehicle at this time. So with greens across the board currently, we are on track for today's liftoff. Now, today's launch marks not only our 4th Electron launch this year, but also our return to the pad following an anomaly with the second stage engine igniter. This was an incredibly unique failure mode that was not identified in our extensive ground testing, including across more than 1,500 engine hotfires and 17 successful orbital missions. But with the issue now well understood and corrective measures in place, we are back on the pad today with an even more reliable launch vehicle. We're grateful for the ongoing support of the FAA and, of course, our customers while we worked through the issue, and we're excited to be back to flight today. So now on to today's mission, to launch a research and development satellite for the United States Space Force. The satellite on board Electron today is called Monolith, and it has been designed to test how small spacecraft can support large deployable sensors.
Bueno, hoy tenemos el lanzamiento del cohete Electron de Rocket Lab, y que ahora voy a dar más información sobre el vehículo lanzador y la misión. Y bueno, como ven, hay unos cambios de que antes no estaban. Por ejemplo, ahora tenemos la hora UTC, que está ahí abajo a la derecha. Y, por ejemplo, la pantalla de inicio, que también antes de comenzar esta pantallita, que también es nueva, y bueno, early experiments that led to the establishment of the satellites that provide GPS around the world were projects launched by the Space Test Program. And we're thrilled to be partnering with this innovative division once again. Let's check back in now on launch operations and take you through our talented team of operators in mission control. Starting with the front row from the bottom left of your screen, we have our MET operator conducting weather checks on things like cloud cover and wind strength and their impact on the conditions for launch. Next, along the front are the RF team who look after our communication systems between Electron estaba poniendo la musiquita que tenemos ahí para que esté de fondo.
Otherwise known as the electrical systems driven by software that tell the rocket how to operate and where it should go. On the second row, starting at the far end and making our way back toward the left, the first operator sitting behind avionics is the propulsion engineer for the mission, or prop. They're responsible for the operation and management of Electron's propulsion system, both its hardware and software, across the first and second stages during all phases of flight. Next to them sits Stage, another engineer who monitors Electron's propellant tank pressures, fuel usage, engine ignition and firing, and overall status of the engines. Moving along, those who sit on the left of the second row are engineers responsible for the guidance, navigation and control of Electron. They monitor onboard navigational systems and guidance computer software on the rocket and are responsible for determining the position of the rocket's first, second and third stages in space. Along the back row at the far end on the right side of your screen is ComOps, who looks after all the data, voice and video communication systems for the launch, and who you can't see in mission control today on the back row normally sits our launch director Adam Slee. But rest assured, he is on console. He's operating from range control at Launch Complex 1 today. Now, a quick look at the clock tells us we are approaching the final no-go poll in a few minutes, which is run by the launch director to determine whether we proceed with the countdown to launch. We'll switch over now to comms from mission control to hear what our operators have to say.
Bien. Me está emitiendo correcto. Después cuando falten menos de 5 minutos para el lanzamiento, le voy a sacar esto. O sea, se ve ahí completo. ¿Y por qué se ve como pixelado esto?
GNCs go.
En teoría está en
Beacon is go.
1080, está en teoría.
T1 is go.
GC.
GC is go.
ELS.
ALS is go.
RSO.
Voy a hacer una cosita.
RSO is go. MET.
That is
En
go.
360, no. 1080.
That is go.
LD sub.
Subs go.
Ahí.
Reynolds station is going
Ahí
over.
quedó.
Sequence is complete. We are
Pero
currently T-minus 11 minutes and 18
se ve
seconds
mal.
and counting.
Bueno, un minuto.
We go for terminal count starting at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
Voy a hacer una cosa.
You heard it for yourself. We have confirmation from Mission Control
Bien,
that all
esto ahora
systems
se
are
va así.
healthy and we are
Esto fue error
green
mío,
for
error
today's
mío.
launch. The T0 liftoff time remains 6 p.m. New Zealand local time or 6 a.m. UTC. For those of you with an eye for detail, you
está.
will have noticed that Electron is not sporting its red stripes for today's mission, which means
Bien,
that this is
ahí
not
quedó.
a recovery launch. We are, though, planning another recovery
Después
test later
de
this
unos
year
errores míos,
as part of our
estamos.
program to make
Tiempo
Electron
menos
a
10 para el
reusable
lanzamiento,
launch vehicle. But today is not that day. We did, however, bring Electron's first stage back to Earth under a parachute on our last mission. Here's a check-in with Peter Beck on what's next for the reusability program.
So the Rocket Lab reusability program now has built quite a lot of heritage. So we started off by just seeing if we could reorientate the stages and just bring them through the atmosphere with no parachute at all. And we did a couple of those and they were very successful. Then we started to actually do fully guided and also start using parachutes to slow the vehicle down. And we've done 2 of those in a row. So we did Flight 16 where we successfully splashed down the stage behind me in the ocean.
Bien.
And then more recently we just did Flight 20 where we made modifications to the stage and brought it back in even better condition. So the program is moving at breakneck speed, and I think we're getting very, very close to bringing in the helicopters and actually seeing if we can pluck
Tenemos
one
la
of these things out of the
recuperación
sky. So we let the atmosphere do
las
all
cofias.
the
Me
work.
parece que es.
Now the challenging part of that is that because the atmosphere is doing all the work, then the rocket experiences some pretty tough environments. But we've been able to mitigate those environments through various thermal protection systems and ride a shockwave all the way through the Earth's atmosphere and tuck in behind it to keep nice and cool. And at the right time, we start popping a parachute and start slowing the stage down. So once we got the 2 stages back, the first thing we do is ironically kind of cut them up. And the first stage, Flight 16 that we brought back, we took all of the components out of it and started cutting up the tanks and understanding how the material properties were affected. And then on Flight 20, we've taken that one step further and we're actually taken the engines out. And those engines will be hot fired down at the engine test cell to validate their life and their performance through re-entry and reusability. All the learnings that we're taking from Electron are directly being applied to the development of Neutron. And if we had to go and build a reusable launch vehicle with no experience, that would be a very,
sí.
very difficult task. But with Neutron, we have all of
Ok.
the learnings from Electron's
Le voy a leer un
reusability
poco
program.
sobre esta
What
misión
reusability
de
actually
Rocket
means
Lab.
for our customers is a vehicle that, firstly, is more responsive.
Bueno, es así. Rocket Lab realizará la misión orbital número 21 con su cohete Electron. Llevará a órbita un satélite demostrativo para el Departamento de Defensa de los Estados Unidos. Me entreveré un poquitito. Disculpen. Este lanzamiento será el retorno al vuelo del cohete Electron luego del fallo de la misión Running Out of Toys, que experimentó una falla en la segunda etapa. ¿Cómo me cuesta leer? Que me parece que fue en mayo. que fue el fallo de esa segunda etapa que no se encendió correctamente. Bueno, tiempo menos 7 minutos. Les podría meter ahí como para mostrarles el fallo. Vamos a venir acá. Bien. En esto está ahí. Parece que te fue. Bueno, el fallo. Ah, esta es la misión de transmisión que falló.
Miko confirmed.
Successful separation.
Staged ignition.
Analyst recovery.
Ahí estuvo el fallo. ¿Vieron? De transmisión que falló.
As you've seen, we've had a successful MECO and stage separation. No, there's been no ignition, sorry, but on your screen, we'll keep that view and see what we can come.
Bueno, ese fallo del cohete Electron fue en mayo. Poco. Falta, vamos a tiempo menos 3,50, 2,35. Tiempo menos 1 les dejo la cosa. en ya se 2 minutos quedan.
Vehicles on internal power. Box load complete, system in recirculation.
Bueno, estamos en tiempo menos 1. Tiempo menos 1. Tiempo menos 1.
Anti-geysering disabled.
Ahora sí estamos en tiempo menos 1. Lo ponemos en volumen.
Stage 1 and Stage 2 are pressed for flight.
5 segundos.
High flow engine purge is enabled.
Como de que va todo bien.
Deluge is activated.
Tiempo menos 30 segundos, vamos.
T minus 20 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2.
We are off the pad and on our way to space once again with successful liftoff from Rocket Lab Launch Complex 1. Right now, Electron is traveling at over 500 kilometers an hour and is passing 3 kilometers in altitude. Very soon, Electron will approach max Q, or maximum dynamic pressure, that moment when forces are at their greatest on the launch vehicle. Let's listen in for the call from Mission Control that Electron has passed that phase.
Vehicle is supersonic. Approaching max Q. Cleared max Q.
There's the call out. Electron has successfully passed through max Q. Propulsion is continuing nominally on the first stage as we approach the next event in Electron's ascent.
Altitude is 30 kilometers, speed is 1.3 kilometers per second.
AOS Chatham Station.
First up, the 9 Rutherford
Safe
engines will
holding
throttle
nominal,
down
standby
before
for
shutting
vehicle
off
approximately
completely,
30 seconds.
otherwise known as main engine cutoff or MECO. Shortly afterward, we'll see separation of the first and second stages, followed quickly by ignition of the single Rutherford engine on Electron's second stage.
15 seconds to go.
Kilómetros.
MECO confirms.
¿Dónde?
As you've seen, we've had a successful MECO stage separation and second stage
Qué
engine
griterío que hay
ignition.
en
Next, we'll be coming up on fairing
el agua.
separation. This is when the two halves of Electron's fairing separate and fall away in preparation for payload
Paración
deployment.
correcta.
And there it is, you saw a
Monta.
flash of it on your screen. The
Lanzamiento.
fairing has separated, clearing the way for payload deployment coming up in approximately 50 minutes from now.
Recuerden que los kilómetros por
Meanwhile,
hora
stage
necesita
2
llegar a
is
27.000
continuing well to orbit,
para
carrying the
cargarse
kick
la
stage and
órbita
the
como
Monolith
correcta.
satellite.
Guidance is nominal.
O sea, órbita correcta no. Entonces, para que órbita necesita estar a 20 kilómetros por hora.
kilometers per
Por
second.
ahí alrededor. Que van en 9.750.
And we are looking at a healthy stage 2 burn at a few minutes and 4 minutes and 5 seconds into the mission, at an altitude of about 10,000 plus kilometers and a velocity of over 165. Electron continues nominally.
Stage 2 propulsion holding nominal.
Space is looking beautiful this evening as our 21st Electron launch has successfully left the pad. We're in the middle of our stage 2 burn, taking us to an elliptical orbit, after which the kick stage will separate in preparation for payload deployment. All systems continue to look nominal. So for those of you just joining us on our 21st mission, you will have heard from Mission Control that everything is continuing nominally during our second stage burn. Ahead of kick stage separation is the battery hot swap, coming up in about a minute. On our way to orbit, we are traveling at a speed of over 13,000 kilometers with an altitude of over 200.
Battery discharge nominal, approaching hot swap in roughly 30 seconds.
14 kilómetros por hora.
Now for one of the events of the launch events unique to Electron, the battery jettison. The fuel pumps in Electron's Rutherford engines are powered by batteries. But once those batteries are depleted, it's just added weight that we don't need to carry all the way to orbit. So we swap out the depleted batteries for a fresh new one
Throttling down.
to keep Electron's second stage going all the way. We call this maneuver battery hot swap, and it's coming up next.
Confirmed.
And there it goes. You will have just seen it falling away, meaning that battery hot
Looking
swap has
nominal.
been completed. Around 2.5 minutes to go until the kick stage separates, setting us up for payload deployment later in the hour. What we're looking at on your screen there is the glowing hot vacuum optimized nozzle for the Rutherford engine on Electron's second stage. It's the same base engine that we use 9 of on the first stage to do most of the heavy lifting. But when we're in space, we only need one. The vacuum optimized nozzle extension allows us to match the pressure of the environment, unlocking some 5,800 pounds of thrust.
HVB battery discharged holding nominal.
Electron's second stage is now approaching SECO, or second engine cutoff. Much like main engine cutoff, the stage 2 Rutherford will throttle down before the kick stage separates ahead of payload deployment. We are now 8 minutes and 13 seconds into flight, and everything is looking great for payload deployment in approximately 45 minutes.
Guidance is in terminal, 20 seconds remaining.
Stage 2 shutdown.
Y bueno, el vehículo está en órbita.
Stage 3 separation confirmed. And nominal planes to orbit achieved.
And that confirms Electron's second stage engine has shut down and the kick stage and second stage have separated. So the kick stage will now enter what we call a coasting phase while it's in an elliptical orbit before its Curie engine ignites to circularize the orbit ahead of payload deployment. Now, we won't have a live video feed from Electron of payload deployment on this mission, but we will stay with you on this webcast to bring you a simulated view of that happening. We'll take a bit of a break on the webcast now, but we'll be back with you closer to payload deployment to listen in on those final moments from mission control. Payload deployment is expected to take place at about T plus 52 minutes, so we'll see you back here then.
So for anyone interested, I'll read out the orbital elements. Our target apogee was 603.83 and we're at 605.15. Target perigee 246.8 and we're at 245.6. And the inclination is bang on at 37 degrees. So we're on track for a really tight
Welcome back to the webcast of Rocket Lab's 21st Electron mission. It's a little chilly up here. If you're just joining us, we have had a successful liftoff and Electron's kick stage is now in an elliptical orbit around Earth. We're coming up to the Curie engine ignition on the kick stage. It's the small but mighty 3D printed engine that maneuvers the kick stage into a circular orbit in preparation for payload deployment.
And Curie has started.
And there you have it, the Curie engine has ignited and the burn is underway to circularize our orbit. This burn has a planned duration of about 50 seconds, so let's listen in to hear for a successful engine cutoff after that.
And stage 3 propulsion is nominal. Stage 3 propulsion is holding nominal. And Curie engine cutoff confirmed.
And that is Curie engine cutoff. Next up is payload deployment of the Monolith satellite for the United States Space Force's Space Test Program. Let's listen in for confirmation.
600, perigee 600, inclination 36.997.
And payload separation confirmed.
So there we have it. Welcome to your new home on orbit, Monolith. That completes our 21st Electron mission and officially brings the count of satellites deployed by Rocket Lab to 105. Congratulations and thank you to our customers at the United States Space Force and the Space Test Program. It's a privilege to be entrusted with deploying your spacecraft safely to orbit. So we've had a successful Electron launch today, but before long, this rocket's much larger sibling Neutron will be taken to the skies. Recently, we shared our plans to develop a 8-ton class launch vehicle tailored for constellation deployment and even capable of human spaceflight. Neutron will usher in a new era for Rocket Lab, supporting our big plans in low Earth orbit and far beyond to interplanetary destinations. And right now, we are hiring. We're currently recruiting talented individuals into the Neutron program across engineering and technical roles in both our US and New Zealand teams. It's an incredibly exciting time to join the team and be part of the next huge step for Rocket Lab. So if you think you've got what it takes to join a world-class team making an out-of-this-world launch vehicle, head to rocketlabusa.com. Before we sign off, though, a huge thank you to...
Bueno, nos reencontramos mañana con el acoplamiento de Nauka. Vamos, siguiente. Adiós.